Okay, so let's wait 1 more minute and then we will get started. Okay, so it's 9:31 now. So let's get started. So I hope all of you can see the screen in which I'm showing my PowerPoint. So if you're seeing the PowerPoint, then you can stay quiet. If you're not seeing the PowerPoint, please let me know. So we have our first exam scheduled for Monday, September 28th. And the exam is gonna be within the time period for the class, which is 9:30, from 9:30 to 11 o'clock on Monday. And you will access the exam using Canvas. So there's going to be a link for the exam in the modules. So as you have been doing for the lecture material, you go to the modules and you go to the date for the corresponding day, and then you'll find a link there for the exam. And the exam is going to open at 9:30. It's going to end at 11 o'clock. And I'm going to give you 15 minutes after 11 o'clock to finalize because some of the problems you're going to have to work on a piece of paper and upload the answers. So I'm going to give you 15 minutes, additional 15 minutes for you to do that. So you can scan the paper, or you can take a good picture of the problem solution and upload the files to the exam. So you will have your time to work on the exam, but remember that at 11 o'clock, and I'm going to talk more about that towards the middle of the review. So from 9:30 to 11, you should work on the exam, and then that extra 15 minutes should be used to upload the material. Like if you end up working more than that and then you don't have enough time to upload the files, then it's not going to be my fault, because I'm giving you that extra time for those purposes. So make sure that you work on the exam from 9:30 to 11 o'clock, and then at 11 you stop, and then you use those extra 15 minutes to make sure that you take a picture or you scan the problem solutions and you upload the files. So I'm going to repeat this again after we go through the review, just to make sure that everybody understands it. Okay, so the exam, again, is on Monday, September 28th is our first exam. And it has 2 sections, as it is stated here at the top of the review. Section 1 is 10 questions that are multiple choice or true or false. These are 10 questions that are 2 points each. So the first section of the exam is 20 points. Okay, so true or false questions are more related to the material in the slides in terms of the concepts. So questions such as if a problem can have multiple solutions, questions about what is an unbound feasible region. Those are the type of questions that you should expect in a true or false or multiple choice question. These are not problems that you're going to solve. These are concepts that you should know at this point. Okay, so those are the 10 questions that you will see at the beginning of the exam. Those 10 multiple choice or true or false questions are 2 points each, and the exam is gonna have that in the corner, saying that these questions are 2 points. And that's the first section, 10 questions that are multiple choice or true or false questions. Then the second section I have here is, these are 4 topical problems that could be short answer, explanation, description, or mathematical. So these are questions that are problems that you need to solve, or it could be a formulation for a problem. I give you a situation and you have to formulate the problem, and or it could be a problem that you have to solve using the graphical method, or it could be a problem in which you have to solve using the Gauss-Jordan method. So those are the type of questions that you should expect in this part. Also, I can give you a formulation and ask you to put the problem into standard form, which we discussed. So these are questions, and these are the questions that I referred to when I said you have to write down the answer in a piece of paper and then scan the solution, because it's gonna be very hard for you to type something like this in the exam. So for those 4 questions, you'll see that I in the exam that there's a statement for the problem, and then there's for you to submit the answer, there's a button that asks you to upload a file. Okay, so let's say I give you a formulation, then you have to formulate the problem in a piece of paper, you write down the formulation, and what I'm asking you to do during this period of time is to make sure that you have a strategy for uploading that file into the exam. So it could be that you've been doing for the homework, that you take a picture, or you have a scanner, but you have to have a way to get the paper, the answer from the paper, and upload it as a file in the exam. So those are the questions. Okay, so the exam has section 2 is 80 points. So 4 problems, 20 points each. So the majority of the weight for the exam is on the problems. So if you have been doing the homework and you've been doing the labs, you should be able to do very well in this exam, because the questions that you're gonna see in section 2 are similar to those that you have worked with during the first part of the semester for homework and for the labs. So if you work on those by yourself and you did well, then you should feel confident that you'll do well in the exam as well. So those are the 2 parts for the exam: 100 points, and first section is 20 points, multiple choice or true or false questions, 10 questions, 2 points each. And then the second section, 4 problems. There's not going to be surprises. These are problems that are similar to what you've been working with during the first part of the semester, and similar to the questions that you've been working with in the assignments and in the labs. And there are 20 points each. So that's the format of the exam. So is there any questions about the format of the exam?
I have a question.
Yes.
So for section 2, you want a separate upload for each individual question?
That's a very good question. And I was planning to address that, but thank you for bringing that point. So as the way that the exam is constructed right now, I gave you for each question a button to upload a file. But if you feel, or if you think that it is easier for you to combine all the answers into a single file and upload a single file in one of those questions, then I will accept that. Okay, so
Perfect, thank you.
Yes, so if you think that's going to save you time or it's easier for you, you can scan all the answers together and upload that file with all the answers in one of the questions for the exam. Hope that makes sense. Any other question about the format? Okay, good. So what I put together as a review for today is I have the set of topics that we have covered as for the first part of the class. So I'm gonna go through those topics, and then I have a slide with some additional information about the exam process. So I'll cover that, and then after that, I have some problems from the homework that I think are representative of what you're gonna be seeing in the exam. So I have those, and I will go through those and ask you if you have any questions about those. So let's get started. So as you can see here, lecture 1 was the review of linear algebra. So we cover topics such as the matrices and vectors, matrices and systems of linear equations, the Gauss-Jordan method for solving system of linear equations, linear independence, the inverse of a matrix, and determinants. So for this lecture, you should expect questions for the first section, like questions such as what is a column vector or what is a row vector? What are matrices? What is the inverse of a matrix? So those are concepts. Okay, so those are important. So you should know those concepts. In terms of the problems, you should expect to see a problem in which I'm going to ask you to solve a system of linear equations using the Gauss-Jordan method. So you should know that. Okay, so that's lecture 1. Any questions? Good. Okay, so let's move to the next page. The lecture 2 was on the graphical solution to LP problems. So in this lecture, we introduced the formulation of linear programming models. And we also introduced how to solve linear programming models using the graphical method. So for the graphical method, the thing that you have to remember is that the graphical method can be used to solve linear programming models that have only 2 decision variables. Okay, so if you had 3 decision variables or 4 decision variables, you cannot use the graphical method. It can only be used to solve problems that have up to 2 decision variables. So again, in this lecture, you can also expect questions in terms of the concepts. So what is a feasible region? Concepts like can a linear programming model have multiple solutions, a single solution, no solution at all? So what is the difference between those cases? So we discussed that in the lecture. So this is the topic, special cases. So it talks about alternative of multiple optimal solutions, infeasible linear programming, unbound linear programming. So those concepts are explained in the lecture, and you should know what the difference are. And then you should also expect to see a problem in which I'm going to ask you to solve a problem using the graphical method. So for that problem, if you have access to a graph paper in which you have those squares, I think that can be helpful. Or if you have so those type of things can help you. I'm not asking you to do that, but if you have access to that, then I think it could be helpful. Try to make your best effort to draw the constraints. Like if you have a ruler, you can use a ruler and draw them, because the idea is that you can identify the optimal solution in the best way possible. So I'm going to design the exam in a way that optimal solution should be an integer. So I'm not going to ask you to guess a fractional value. So, but if you use a graph paper and you use a ruler, I think those things can help you to go faster in terms of solving this type of problem. So that's my recommendation. So what I'm looking for here is that you are able to draw the correct constraints, that you are able to identify the feasible region in the problem, and that you can draw the isoprofit line, and then you can use the isoprofit line to identify the optimal solution. Those are the things that I'm looking for in this type of problem. Questions? No questions, good. So the next lecture is on formulation of linear programming problems. So in this lecture, we cover different type of problems. The idea for this lecture is that you got familiarized with problems that are common and that you can solve using linear programming. So we cover, and those are outlined in this lecture 3 section. We cover different type of problems like the diet problem, production planning, and the multi-period production planning and inventory control, manpower, which are scheduling problems, project selection, and the blending and refining. So the idea for this lecture is for you to start seeing different applications and then get familiarized with, if I have a production scheduling problem, these are the decision variables that are typical for that type of problem. And these are the constraints, and these are how the constraints look like for a production planning, a single period production planning problem. And this is the objective function. And same thing for the scheduling. So if I have a scheduling problem, this is how the decision variables are set up. This is how the objective function is set up. And these are the typical constraints for a scheduling problem. Same thing for the project selection. So in this lecture, you have a good variety of problems and formulations that can help you get an idea, and that creates a library for you to remember or to recognize. So when you see other problems, you can say, okay, this problem looks like the single period production planning problem. And then you will say, okay, if this looks like a single period production planning problem, so I know the decision variables should be like this, the objective function should be like this, and the constraints should include this and that. And if you see a problem that is a scheduling problem, then you can think about the bus scheduling and the post office and say, okay, this is the scheduling problem. These are the decision variables. These are the constraints, and this is the objective function. So that's the idea of this lecture. So as you read through these problems, I want you to be able to say, okay, if I have a problem that is like this, I should understand that, because and then I can remember how the constraints, how the decision variables, and how the objective function are defined for those type of problems. So if I show you a problem like that in the exam, you can connect that to, okay, this looks like this problem that we discussed in class. I know how to set up the decision variables, the objective function, and the constraints. So we have a lot of practice with this in the labs and in the assignments. So hopefully at this point you have a good idea of how to formulate some of these problems. So in the exam, you should expect to see a formulation problem. That problem is going to be different from what you have seen in the homework in the exam in terms of the details of the problem, but you should be able to connect the strategy or the formulation of the problem to one of the problems that we discuss in class. So if you're familiar with the problems that we have discussed in class, then you should be able to formulate that problem that is going to be presented in the exam. Questions? Okay, so the last lecture is lecture 4. This lecture, we cover half of it. We covered the introduction to the Simplex algorithm. So how do you go from the graphical method to the algebraic method, which is the Simplex algorithm. But we didn't go into the details of the algorithm yet. I didn't want to include that as part of the exam, so we stopped right in the middle of the lecture. We're going to start with the Simplex after the exam. So the idea for this lecture is that you know how to set up your problems to apply the Simplex method. So we talk about the how do you convert LP or linear programming models into standard form. So you can add subtract the excess variable, and you can add some slack variables depending on the type of constraints that your problem have. So the idea is that if you have inequalities in your constraints, that you can make those inequalities equalities by adding slack variables or subtracting excess variables. So you need to know how to convert problems from typical LP problems in and make them or convert them into a standard form. So also, we discussed the transition from graphical to algebraic solution. So so this is where you you can identify if you have a problem. You can identify from the graph using the algebraic method. You can state where the solution is using setting up your non-basic variables equal to 0 and solving for the rest. And I think the homework or the assignment that is due the day of the exam is connected to this material. I posted the solution for that assignment already because I want you to have that solution to study for the exam. You still need to submit the assignment, so you can use the solution. I mean, you can refer to the solution to complete that assignment, that's fine. But that assignment, the solution for that assignment is already posted, and I think I have those problems also as part of the review. So we're gonna go over them today. So that's this lecture 4, the simplex algorithm. Any questions about this one? So remember that I'm recording this, so the video is going to be available also after class. I mean, I need some time to set up the video in the Canvas side, but should be available this afternoon. So how to prepare for the exam? Best way to prepare is to study the lecture slides and review the labs that we have covered, and also the assignments and the homework. So if you have a good understanding of the material that was presented in class, in terms of the concepts, and you know how to solve the labs, and you know how to solve the problems in the homework, in the assignments, you should be fine. You should do very well in this exam. The exam is closed book and notes. So what that means in this online virtual environment is that those modules that you have access to right now, those modules are going to be, I'm not going to have them published. So they are going to be unpublished during the exam period. So that's going to happen. So you don't have access to that information during the exam period. So the modules are going to be unpublished. The material is not going to be available during the exam period. So the notes are not going to be available, and the answer to the assignments and to the labs are not going to be available during the time of the exam. Clearly, just show your work and formulas used in your solution. So if when you're solving these problems, make sure that you show your work. Even if at the end that can help you, the solution, the final solution is not right, I can still award you full or partial credit based on the work that you perform in the solution. So make sure that you show your work. The multiple choice questions or true or false questions will be answered using the computer. So those are simple to answer with them. I mean, just click on the right answer, and that's all you have to do. For the 4 questions problems, you have to upload a file. So again, as I mentioned already, work solution in the paper, take a picture or scan and upload your solution or file. You will have 15 minutes to upload the file. So what that means is you have access for the exam starting at 9:30. Okay, and then you will work on the exam until 11. That should be more than enough time for you to complete this exam. So you have an hour and a half to work on the exam. However, I'll leave the submission portal open until 11:15. Those extra 15 minutes should be used to upload your answers. Okay, so what I'm trying to avoid here is that you, at the end of, at the end of the exam, you tell me that you didn't have time to upload the file. So I'm giving you that extra 15 minutes to upload the material. Okay, so those 15 minutes should be enough. So the exam is from 9:30 to 11. At 11, you should stop working. Okay, this is something that you have to do in order to have enough time for you to upload the files to the Canvas site. Okay, so make sure that you follow those instructions, because if you work until 11:15 and then you send me an email saying that you were not able or you don't have time to upload the files, well, remember, those 15 minutes after 11 should be used for those purposes. Okay, any questions? So I'm aware that some students are based on the letters that were submitted to me at the beginning of the semester. I'm aware that students have, there's some students that will require some extra time. So I already put that into the system. So that's going to show up in the exam portal. So if you haven't submitted that letter, if you are one of the students and you have not submitted that letter, you need to send me that letter so I can accommodate the time based on your needs. Okay, so hey, any questions? Okay, so let's see. So at this point, I just have some problems from the homework that I selected. So based on the office hours, there's some students that have been asking about these problems, and also via email. So I decided to show the solution for those, and then ask if there's any questions about them in specific. So these are coming from assignment 2. These are problems that ask you to formulate and to solve linear programming models using the graphical method. So this is problem number 1. So the idea for this problem was for you to formulate first and then solve. So remember that when you formulate a problem, you have to show different things. And you start with the, let's see, the decision variables. So decision variables, okay, so you show me the decision variables, you state your decision variables. You also have to state the objective function. Okay, so the objective function should be in terms of maximization or minimization of z, and there's an equation associated to it. And then you have your constraints. And there's also, don't forget about the non-negativity constraints. So they should be x1 and x2 greater or equal to 0. So once you have set up the problem, in this case, we have 3 processes that are used to produce these 2 products. So we have a decision variable or 2 decision variables that are associated to the number of products that you are going to produce of each type. And then we have 3 constraints that are associated to each one of the processes. Those constraints are here. So for the first constraint, we have, it takes 10 minutes or 10 time units to 10 hours. I'm sorry, 10 minutes. 10 minutes to complete the first product in the first process. It takes 6 minutes to complete the first product in the second process, and it takes 8 minutes to complete the first product in the third process. And for product number 2, we have similar information, and then we have also the profit that we get by selling each one of these products. So one of the questions that I get a lot is, how do you know when you are maximizing or minimizing? So the answer for that is going to depend on what information you have available for your problem. Like for this problem, we have the profit. Okay, so that's the information we get for this problem. So obviously, if you're talking about profit and you're running a business, you want to make sure that you maximize the profit. However, if instead of having profit, you're given information about the cost, then is the opposite. Because in terms of cost, you want to minimize the cost for your production schedule. If you are given both, like if you are given revenue and cost, then you have to use that information to compute the profit. So you have to find a way to combine that information and find the profit and then maximize that profit. Okay, so profit you maximize, cost you minimize. If you're given both pieces of information, then you have to find the profit. If you get the revenue and the cost, then you have to find the profit mathematically and then use that information to maximize the profit. Okay, so we have a constraint for each one of the processes. So we have 10 hours a day for each process to produce parts 1 or product 1 and product 2. So 10 hours is in minutes are 600 minutes. So this is our formulation. And then we can use the graphical method to solve this problem because this is a problem with 2 decision variables. Okay, so we can apply the graphical method. In this problem, we have 3 constraints, and those are plotted in this sorry, let me. Okay, so this is what we have. These are plotted here, each one of the constraints. Sorry, take this. Just 1 minute. What's going on? Okay, 1 minute. I need to fix this problem. Okay, so here we are. So we have constraint 1, constraint 2, and constraint number 3. Okay, what is not shown in this problem is the isoprofit line. Okay, so for you to find the optimal solution for this problem, you have to draw your isoprofit line. So in isoprofit line, you have to use the objective function. So the objective function is 2x1 plus 3x2. And then you have to find a point in the feasible region. So let's say this is your feasible region. So to draw the isoprofit line, you need 2 points. We can start with a point in inside the feasible region. So let's say this is, I'm just gonna use a point 10, 10, because I know 10 is going to be in the feasible region. So I will use 10, 10. It is a point in the feasible region, so I'm going to substitute that point into the objective function. This is 2 times 10 plus 3 times 10. This is equal to 50. So for x1 equals 10, and x2 equals 10, the objective function value for this equation is going to be equal to 50. Okay, so I have my first point, and I have to find a second point in which the line or in which the objective function is also equal to 50. So for you to do that, we can refer back to the method that we use, the simple method of setting one of the decision variables equal to 0 and then solve for the other one. So let's say I let x2 equal to 0, then I can solve this equation. 2x1 plus 3 times 0 equals 50. Then I get 2x1 equals 50. Then x1 is going to be equal to 25. So my second point that gives me an objective function equal to 50 is x2 equals 0, x1 equals 25. So I now have 2 points, 10, 10, to draw my isopropyl line, and 25 and 0. So using that information, I can plot that line. So that would be, let's say this is 50, and I'm doing an approximation because I know this is 100, so this will be 25. So this point right here is 25 and 0. So this is my first point. And then I have the other point that is 10, 10. So again, that's an approximation. Going to be around here. So now I have 2 points, and I can draw this isopropyl line. So I have my isopropyl line, and I can use that isopropyl line to find the optimal solution for my problem. Since we are maximizing, we want to find the last point in the maximization direction, which is this one, that touches the feasible region. So if I move this line parallel to it, I know that the last point that I'm going to touch, if I move in this direction parallel to it, the last point that I'm going to touch in that feasible region is going to be this point 8. And that's the optimal solution. Optimal solution occurs at point 8 with x1 equals this number, 52.94, and 14.12. So one of the questions I get is, so if it is a fractional value, do you want us to get that exact number? The answer is no. I want you to get as close as possible, but I'm not expecting you to give me a 52.94. So if you approximate that to 52 or 51 or 53 or 54, that's fine. That's fine. The idea of what I want to see from these problems is that you are able to set up the constraints in the right way, set up the lines for the constraints in the right way, that you can you can identify the feasible region, and then you can use the isopropyl line to tell me where the optimal solution should be. Okay, so any questions? Okay, so the next couple of problems are similar. So you are formulating and you are setting up the graphical method, and then you identify the optimal solution. So I think the next one is the same. So here we have the isopropyl line, right here. So if you understand this, then you should be able to get those 20 points easily. Then we have some formulation problems, and again, these are coming from your assignment. So in this case, we have 4 products that are processed sequentially on 3 machines, and we get the information. So in this problem, we have capacity for the machines. Each one of the machines has specific capacity. So when you see this information, right there, you know that those are constraints, because every time you see a capacity limitation, that's constraint. So your constraints should be associated to that capacity. And in this problem, you also have information about the cost and the profit, the revenue. So if you have those 2 pieces of information, then you have to compute the profit and use that as your objective function. And every time you see a manufacturing process with different products, then this is a production scheduling problem. It's a single period production problem. You're trying to decide how many of each product you want to produce, and we have a problem in the lectures that covers that. So if you follow that single period production planning model and example, you'll see that the constraints are similar to the ones in this problem. So you have the constraints. Well, your decision variables obviously is how many of each product you are going to produce. And then for the objective function, since you have the information about the revenue and the cost, you have to use that information to compute the profit. And then using the profit, you can state your objective function. So you see the profit here is associated to each one of the decision variables in the objective function. And then the constraints are, as I mentioned, they're linked to the capacity of your system. So if you can identify the capacity, you know that those are the constraints, and those are your constraints here, and they are associated to the time each one of the products spent on each one of the machines. So product 1 spends 2 hours, product 2 spent 3 hours, product 3, 4 hours, and for product 4 spent 2 hours in machine 1. And you know that you have 500 hours available. So your constraint is going to try to make sure that you don't use more than that during your production. So you want to make sure that if you decide to produce a certain amount of each one of the products, that at the end you cannot use more than 500 hours of your first machine. And that's the same thing that happens for machine number 2 and machine number 3. So decision variables, so you identify the decision variables. In this case, the production problem, decision variables are associated with the number of units that you're going to produce per product. So X1 is the number of units that you're going to produce for product 1, X2 is the number of units for product 2, and so on. The objective function is associated with the profit that you are going to make when selling each one of these products. Okay, so in this case, you have information about the selling price and the cost per hour for producing each one of the products. So you use that information to compute the profit, and then you maximize that profit. And the constraints are associated with the capacity limitations of your production. Any questions? Okay. So in this one, we also have a manufacturing process. In these produces 3 models. using a certain product using raw materials A and B. So instead of having machines, now we have raw material. And this is still a production problem in which we have a capacity limitation in terms of availability. We have 3 products, and we have the price per unit. And in this problem, we also have the minimum demand. So we also have some extra information about the labor time per unit of model 1 is twice that of 2 and 3 times that of 3. The entire labor force of the factory can produce the equivalent of 1,500 units of model 1, and market requirements specify the ratios of 3 to 5 for the production of 3 respective models. Formulate this problem as a linear program. So if you look at this problem, it has some additional information or some additional constraints that were not seen in the previous problem, but some of the constraints are still the same. And actually the decision variables are the same. The objective function is still similar, and the first 2 constraints are the same. So these 4 parts are, I mean, details are different, but they're written in the same way that we wrote them in the previous example. So we have some additional information that is in terms of the labor and also in terms of the number of total units that we can produce. And those are also capacity limitations. We have some ratios that needs to be satisfied, and those are these 3 additional constraints. Those ratios are defined by those 3 constraints. So the first one is the entire labor force of the factory can produce an equivalent of 1,500 units of model 1. And then we use the information of the ratios to make sure that we don't exceed that amount. So X1, you can produce at most this amount. So if you end up producing only X1, you know that you cannot exceed 1,500. But the other 2 products are associated with you use that first product as your baseline to compute the ratios for the other 2 products. So these ratios are right here, and those are that's the information that we are trying to encapsulate right here. I'm sorry, the labor time is what we are trying to model right here. So labor time per unit of model 1 is twice that of 2 and 3 times that of 3. So that's what we are trying to encapsulate here in this constraint. And then the ratios are the ones that are covered in these 2 last constraints. So this problem is a little bit more challenging in that sense. But once you see the solution for the first time, once you can see how those constraints are managed, then you can refer back to this problem when we're faced with a similar problem in the future. So this problem was not part of the problems that you need to submit for the assignment. Okay, these were additional problems that I put there for you to consider, to think about. And now that you see the solution, you can refer back to this problem when you see something similar in the future. See, problem 6. This problem was part of the problems that you needed to submit. So this is very similar to the multi-period production scheduling problem that we discussed in class, in which you have inventory and you have to model your number of the number of units that you're going to produce per period. So, so the solution is here, and you can refer back to the solution in the lecture. Is very similar. This one is also similar to one of the problems that we covered. I think if you look at the post office scheduling problem, you'll see that this problem is very similar. You had to identify how many people are going to start working at a specific time period. So that's what we have in this problem. So same strategy. So again, if you know how to formulate scheduling problem, you can use that format to address similar problems, just like this one. And the next one is also a scheduling problem. This is similar to the bus scheduling and also to the post office scheduling problem. So the solution is already posted in the modules for the class. These review slides are also available. So any questions about any of these problems before I continue with the last part? Okay, so let's see. This is connected to the last assignment for this first exam, assignment number 3. So this assignment is related to the simplex and how to go from the graphical to the simplex algebraic solution. So what this is asking is show how the basic feasible solution to the LP is standard form corresponds to the extreme point of the feasible region. Okay, so the first thing we have to do is to set up this this problem into the standard form. So how do you make this into a standard form? Then you have to add or subtract, add the slack variables or subtract the excess variable depending on the type of constraints that you have. So in this first constraint, we have, so if I want to put this constraint into standard form, I have 2x1 plus x2 plus s1 equals 100. For this other constraint, I have x1 plus x2 plus s2 equals 80. And then for this third constraint, I have x1 plus s3 equals 40. So those are my constraints. Those are the inequalities. So those now are set up into the standard form. Then my objective function is to maximize z equals to 3x1 plus 2x2. And my decision variables, x1, x2, s1, s2, and s3 has to be greater or equal to 0. Okay, so that's the formulation in standard form. Now I want to show that the points that are in the graph are corresponding to the solutions that I can find using the algebraic method. So if you remember the discussion, we had to find out, now that we have the formulation into standard form, which ones, how many basic variables and how many non-basic variables we are going to have. Okay, and then we can compute that based on the number of decision variables and the number of constraints. that we have. Remember N and M. Okay, so N is the number of variables. N is the number of constraints. And the number of non-basic variables equals N minus N. Okay, so I have how many variables? I have 5, x1, x2, s1, s2, s3. So I have 5, and I have 3 constraints, 1, 2, 3. So the number of non-basic variables equals 2. Why is that important? Because the number of non-basic variables, those are the variables that you can set up equal to 0 and then solve for the basic variables. Okay, so in this column, now I'm showing the different combinations that can be made based on these 5 decision variables. Every time that I choose 2, setting up them equal to 0, I solve for the rest. So I start, these are the different combinations. So if I choose x1, x2, and s3 to be my basic variables, then s1 and s2 are going to be the non-basic. So the non-basic variables are going to be equal to 0. So if I set up s1 and s2 equal to 0, I can find the values for x1, x2, and s3 by substituting those values into this. Okay, and then by finding those values, in this case, when I set up s1 and s2 to be equal to 0, and I solve for x1, x2, and s3, x1 is equal to 20, x2 equals 60, and s3 equals 20. However, when I try to find those points in the graph, I know that my graph is stated in terms of x1 and x2 only. Okay, so even though I'm getting some values for S3, S1, and S2, those are not values that I can plot in the graph. So when I identify the values, when I identify the points in the graph, I have to use the values for X1 and X2. So in this case, I have X1 and X2, X1 equals 20, X2 equals 60. That point is this point right here. And that's why I identified this as the point represented by those basic variables. And I can repeat the process. Let's say I chose S1, S2, and S3, those 3 as my basic variables, and then the rest will be non-basic. So I have to set up X1 and X2 equal to 0. When I solve for the S1, S2, and S3, I get 100, 80, and 40. When I try to identify that point in the graph, since S1, S2, and S3 are not part of the graph, I have to use X1 and X2. So for X1 and X2, I know those are 0 and 0. So the point that is identified in the graph is point H, which represents 0, 0 in this graph. And I can repeat the process until I find all the points in the graph. One that is, let's see. Yeah, so at that point I have identified E, D, and F. But if you continue the process, you will also find this point here, and you will also find this point here. Even though they are not part of the feasible region, if you list all the possible combinations, you can also find those points. For the solution, I just identify those points that are part of the feasible region. So G, H, E, D, and F. Is this clear? I'm not going to ask you to do this in the exam. What I want you to do, or I mean, what you should be able to do is to formulate a problem into standard form. That should do it. You should know that. But in terms of going through the process of identifying each point in a graph, that's not going to be part of the exam. However, I want you to have that understanding because that's going to be important for what we're going to do next. So you need to understand what are the basic variables, how to identify basic and non-basic variables. Why are we splitting them in two groups? The purpose of splitting them in two groups is by setting some of them into a values equal to 0, then we can solve for the rest and we can identify a point in the feasible region that can be an option for an optimal solution. So any questions about this? Okay. So the next problem is similar. I think it's the second problem for the homework. So this is the solution. So again, you need to understand how to set up the problem into standard form, but understanding how to identify those points is going to be more relevant for what we're going to do next after the first exam. So this assignment is due the day of the exam. I have posted the solution, so you can go see the solution in the modules. You still have to submit it, so make sure that you submit the assignment, and that's the review. So I now have the opportunity for you to ask questions. If you have any questions.
Are we going to have to log into the Zoom call for the test?
I'm not familiar with that. Is that a system that you have?
Like join the Zoom while we take the test. Like, do we have to do that?
No. So something that I don't do. I don't do those things. So I will trust you guys in the sense of trust you in the sense that I trust you guys that you're going to be working independently. I can tell you, I mean, I'm not going to reveal all my secrets, but if you work independently, it's going to be for your best benefit. The exam is designed in a way that if anybody tries to work in groups, then one of the two will fail. So make sure that you work independently in the exam, and make sure that you use your time wisely. But I mean, to answer your question, no. You will be working by yourself in the exam with a computer, and then that's all. And then make sure that you use your time wisely, and that's very important. So you need to prepare for this exam. I mean, I'm not there to see whether or not you're using your notes, but remember the modules are going to be unpublished, so you're not going to have access to the modules during the exam and to the homework assignments or to the lectures. So you have to prepare, and the time is enough for you to complete the exam. And I'm going to repeat this one more time. You have from 9:30 to 11 to work on the exam. That extra 15 minutes that you will have from 11 to 11:15 has to be used for you to upload the material for the problems. Okay, so if you email me after the exam saying that you didn't have enough time to upload the material, I'm making that very clear now that you should use those 15 minutes at the end for those purposes. So at 11 o'clock, you should stop, and then you should use that extra 15 minutes to work on uploading your work. Any questions? Okay, Good. So if you guys have any other question and you feel better asking that question by yourself, I'm going to have office hours today from 2 to 3:30. So the link is available in the Canvas side and also in the syllabus. So you can join my office hours today from 2 to 3:30. And I can address those questions individually if you have any questions. Okay.
Last question, and this lecture is gonna be published, right?
Yes.
The
So
review lecture?
this review, I am recording this lecture, so I'm going to post the video and also the slides. Yes.
Okay.
Yes. Any other question? Okay, sounds good. So I'll meet with you in the office hours. If not, then remember the exam is on Monday. Bye-bye.